Today, we're diving into a paradox that's right at the heart of modern AI. We've got these incredible models that can write poetry, that can generate code, and yet they can completely fail at something a 10-year-old can do with a pencil and paper, multiplication. So let's figure out why.
Okay, take a look at this problem. It's a pretty straightforward 4 by 4 digit multiplication, right? Any pocket calculator could solve this in a fraction of a second. And yet, some of the most powerful, most advanced large language models on the entire planet will get this wrong, and get it wrong consistently. How is that even possible? Well, that's the central mystery we're going to solve today.
And you know, this isn't just some random glitch or a one-off bug. It points to a really fundamental weakness. When you train a huge transformer model the standard way, which is basically just showing it millions of math problems and then showing it the final answer, it just fails. It fails to learn the underlying process of multiplication. It completely gets stuck.
And hey, don't just take my word for it. Researchers have dug into this, and as our source paper points out, even massive models with billions and billions of parameters just hit a wall. And that tells us something really important. You can't just throw more computing power at this. There's something more fundamental that's missing here.
So to figure out what was going on, the researchers set up this really fascinating experiment. They took two AI models and they trained them on the exact same task, but they used two totally different methods. And what they ended up with was a failing student and a secret genius. By comparing the two, they could finally uncover what was going so wrong.
So on the left, you've got the SFT model. That's our failing student. It just saw the problem and the final answer, and it totally flunked with less than 1% accuracy. Just terrible. But on the right, you have the ICOT model, our secret genius. It was trained using a special method called implicit chain of thought, and it aced the test, a perfect score. So, what was this magical training method? Well, the ICOT method is actually pretty clever and intuitive. First, you show the model how to do the math step by step. You know, just like you would with a student. You show all your work. Then, slowly, over time, you start hiding those intermediate steps. You take the training wheels off. And what this does is it forces the model to stop just copying from the scratch pad and to actually learn to perform those steps inside its own neural network. It has to internalize the logic itself. Okay, so now we have a model that can actually do multiplication, which is great. The next obvious step for the researchers was to pop the hood. They wanted to reverse engineer this genius model to figure out what kind of internal algorithm it had actually invented for itself to solve the problem. And what they found was that the secret sauce is something called long-range dependencies. Just think about it for a second. To calculate one of the middle digits in the final answer, you have to combine information from